Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the structure. The compound is CH3, CH is equal to C, Br, C, Cl is equal to CH, CH3, a diene with two double bonds, one between C2, C3 and another between C4, C5, using a 6-carbon chain numbering. Each double bond is a site of potential geometric, CH3 or EZ, isomerism. Moving on to the next step. Check each double bond for geometric isomerism. Double bond 1, CH3, CH is equal to C, Br, dash. The two groups on C2 are H and CH3. The two groups on C3 are Br and the rest of the chain. Since C2 has two different substituents, H and CH3, and C3 has two different substituents, Br and the C4 portion, this double bond can exhibit EZ isomerism. So two configurations here. Double bond 2, C, Cl, is equal to CH, CH3. The two groups on C4 are Cl and the C3 portion, the two groups on C5 are H and CH3. Since C4 has two different substituents, Cl and C3 portion, and C5 has two different substituents, H and CH3, this double bond can also exhibit EZ isomerism. So two configurations here. Moving on to the next step. Calculate total geometrical isomers. With two independent double bonds, each capable of E or Z configuration, the total number of geometrical isomers is equal to 2 times 2 equals 4. And for the final step, check for any mesoform reduction. In this compound, the two double bonds bear different substituents, Br versus Cl, so no meso cancellation occurs. All four combinations, E, 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 Z, Z, E, Z, Z, are distinct. Why other options fail? A. 2 undercounts by considering only one double bond. B. 3. Incorrect, no mesoform eliminates one of the 4 isomers here. D. 6. Overcounts, there is no additional source of isomerism beyond the two double bonds. Therefore, the correct answer is C. Therefore, the correct answer is option C.